Hi, I'm Samir Shende from the University of Oregon, and I'll be talking about E4S, a platform for CI/CD for HPC and AI. So we have three main parts that I want to describe in this talk. The first one is about E4S and what it can provide to you in terms of containers that can be used for CI projects. We are working closely with the HPSF CI working group, and we are running a lot of workloads on AWS as well as on Frank at the University of Oregon. And these workloads are powered by, some of them are powered by E4S containers that I'll describe, and also all our infrastructure is based on SPAC. I want to also describe the E4S features, how E4S features custom SPAC-based containers with support for GPUs. And in case you are wondering about your project and how your project can get access to these CI resources using the containers on Frank, you can reach out to the HPSF CI working group, and I have some URLs over here. So first of all, what is E4S? E4S is an HPC AI software ecosystem for science. And it's an effort to provide open source HPC and AI packages in a form that lowers the barriers for entry into this area. We have containers. We have base containers, full-featured containers, containers with vendor runtimes, and we have images that run on 5 different cloud providers, including AWS, Google, Azure, Oracle, and IBM Cloud. And we have SPAC binary caches, which can simplify the deployment of the packages for you. We have support for 3 different architectures, x86 64, we have AR64, and even IBM PPC64 LE. We have AI and ML packages and HPC packages that are optimized for GPUs of different architectures, and container images that are available for download from Docker Hub as well as the E4S web page. We also have a couple of other tools. One is called E4S chain SPAC.sh, which allows you to chain 2 different instances, one instance of SPAC in a read-only file system with another in your home directory, so you can see the union of packages and just SPAC install additional packages very easily. There's a E4S CL container launch tool that allows you to substitute the MPI in the containerized application with the system MPI. And we have an E4S ALC tool that allows you to customize your container by starting with a base image and then adding more packages to it and creating a new container. So this is the E4S web page. You can interact with a chatbot that's hosted on this. It's RAG trained on a number of packages that are part of E4S distribution, and Mike Hiru here has developed that RAG-trained chatbot, which is part of the web page. You can download the containers, and then you can run these on GPU clusters. So the one particular GPU cluster that I want to describe today is the Frankenstein Frank cluster at the University of Oregon. And we have a number of different servers. I think there are like 40+ servers that we are hosting. And these servers are used for the CI workloads. Here are some of the GPU-enabled systems. We have support for Grace Blackwell, x86 Blackwell with RTX 6000 Pro GPUs, RTX 5080 GPUs. We have Grace Hopper systems. In many cases, we have 2-of-a-kind systems connected with a high-speed network between those 2 nodes. So you could have like 2 Grace Hopper systems or 2 Grace systems connected by InfiniBand with, say, 400 Gbps network between them. We have a suite of AMD GPUs. I'm just showing here the Quad MI300A system. Intel Ponte Vecchio, or the Data Center Max 1100 series systems, the Battle Mage or BMG, B580 ARC GPU. In fact, our goal is to have one GPU of every architecture from Intel, NVIDIA, and AMD. We also have the HPE Cray programming environments with Red Hat Enterprise Linux as well as SUSE Linux. And you can run your workloads on those systems. We have ARM AR64. You can see Grace Hopper, Grace Blackwell, even older generation of Oren, Xavier, Tegra clusters as well, and PPC64LE, Mac OS X, M1, M4, and Windows. Now this is a new development. We have started hosting Windows systems here, and you can learn more about Frank at this URL. If you are wondering how do you access Frank for CI jobs and what does the GitLab integration look like, so we have GitLab runners that are running on all these Frank nodes. They are registered with gitlab.spac.io and gitlab.e4s.io. We have a Docker executor for reproducibility. We have GPUs exposed via docker config.toml settings. And then runners are tagged. So you can see a tag like HPSF GPU, NVIDIA-RTX 6000, etc. And this is how it works. There's the Frank systems. We are connected to the SPAC GitLab instance. And then the GitLab to GitHub sync can happen. And you may be interested in Hubcast as well. So we also have a monitoring website called stats.e4s.io that can show you the exact number of jobs that we ran on different architectures. There are some category of jobs that are not represented here. These include the jobs from Intel and AMD. AMD is doing ROCm CI over here. Those jobs are not shown over here. And some of the Intel jobs are not shown over here. But the rest of them show you how many jobs we are running. And typically, each job can take maybe 10 minutes or something like that. And we have the Frank hardware is used heavily for SPAC CI. There's the SPAC core, SPAC /SPAC, as well as the SPAC packages. We have Mac OS and Darwin jobs that are run exclusively on Frank. The HPE Cray PE jobs are currently run exclusively on Frank, and the GPU jobs are run over here. But the other jobs are split between AWS and Frank. And recently, we have added a lot more capacity for the runners, and that has increased the number of jobs running on Frank to about 60 to 70%. This is from last night. I see that about 73% of jobs in the last 72 hours, they ran 19,500 jobs. And here are some of the jobs. If you want to look closely, there are jobs running on HPE Cray CI jobs. There's high energy physics, machine learning, Radius, SPAC CI, and now we are ramping up Windows visualization jobs with 73% on UO. And this is over a whole week. You can see it's about 63% UO, 37% on AWS. They ran over 47,000 jobs. And I'm happy to report that we have a whole set of servers now for Microsoft Windows CI. Here is a typical setup for different Windows machines. And you can see there's a VM now which has 64 cores, 128 GB RAM. And these are the Mac OS runners on Frank. You can see the AR64 support, and there are different machines, like we have M1, M2, M4s with a number of these systems. Here are some examples of the SPAC jobs running on this CI. Here's, again, on Mac OS, machine learning, TensorFlow builds on the CI. And just in case you are wondering what kind of HPSF projects and other projects are running on Frank, so there's Viscourse, Adios2, SPAC, there's Vorpex, Ambrex, HPC Toolkit, Tau, E4S, even Intel PTI GPU, and Cocos and Trilinos. And here is a Tau nightly CI running using the E4S containers on Frank. And you can see that there are 15 different GPUs. 15 different GPUs on which we are building Tau with MPI and Cocos and using the GPUs. So we are measuring the performance of that application using Tau. And you can see the output here. You'll see Cocos parallel 4 figuring prominently in the output of the pprof output. And this is running on 15 different GPUs. So we are exercising MPI, Cocos, and the GPU runtimes on Intel, AMD, and NVIDIA GPUs on multiple ranks. Here is E4S containers powering the Trilinos CI on Frank. You can see over here the Docker pull on the ECP E4S and the E4S image that's used. So these images have a number of these packages, and they can be customized. So you can also use other images from outside of E4S for some of these workloads. Here's Trilinos CI running on an NVIDIA Blackwell RTX 6000 GPU. This GPU has like 24,000 CUDA cores on it. And you can see that it ran 564 tests on 7 different NVIDIA GPUs. On each of those, here is Intel PTI GPU CI, where we are using the ECP E4S container for the Intel testing on different GPUs. This is on, I believe, on a Ponte Vecchio Data Center Max 1100 series, and the Battle Mage B580 GPUs, all E4S containers. And here is the HPC Toolkit CI on Frank running on Ponte Vecchio. But you can see the different architectures on the right side and the pass or failure of the tests. I'm not sure if you can read it clearly, but there are like 3 tests that failed, and you can see which ones and what was expected. So this shows you how it can be used to track failures on one architecture which do not occur on all the other architectures. And here is the Viscourse CI pipeline on Frank, and you can see all the different architectures. And here is a pass-fail checkbox which says Frank CI, it has passed. A job output for the MI100 GPU for Viscourse, and CI pipeline with 21 minutes running on, say, A100 GPUs. So this exercises the actual software on the target GPU. Ambrex, in this case, 178 tests ran in 22 minutes on AMD MI300A GPU. This is Cocos CI on a Grace Blackwell GPU. And you can see different GPU architectures listed on the right. In short, I would like to just say that E4S containers can be customized for your SPAC-based project. GitLab runners can be customized for your GPU-enabled workloads. And please contact us if you would like to run your project CI on Frank. We can customize the E4S containers and get the CI working. Please send an email to me as well as to Zach at Kitware, and we can just hook up your project, whether it's on GitLab or GitHub. And I would like to conclude by saying Frank at the University of Oregon is a viable platform for HPSF CI. It's currently hosting 100% of the HPSF CI jobs on GPUs. There are no fees for projects for HPSF, and this is a compelling reason for projects to consider joining HPSF too, to get free CI cycles. And I would like to thank the US Department of Energy Office of Science and various projects that are supporting this, as well as the ECP and HPSF. So any questions? Yes, Jed?
When things go wrong in CI, it can sometimes be hard to figure out why is it going wrong. You know, it works in my local computer, why is it working in the CI? What kind of tools are available to help work around that?
So, first of all, you can browse the full verbose output of your job on the web. We can also send the output to C-, so you can monitor it in a matrix form of which jobs are failing on what architectures. And this is typically used by projects like Cocos. And we have grafana.spac.io that can also be used. And we can give you access to the machine if you want to log in and try running the job and debug it. And we have some tools like TotalView installed with a remote graphics through a web-based interface so that you can debug your jobs. And we store all the logs. We are not deleting them quite yet. So all of those things can help. Yes? Yes, SPAC should be the primary platform that you use, and then we can build containers with SPAC and deploy them. Yes?
Does it have to be like so if I have an application that's not currently in SPAC and I make a SPAC recipe for it, is that good enough?
Yeah, we can work with you with that, absolutely, yeah. We can create a custom E4S container with that SPAC recipe and create the container and run it. We just need to know, how do you build the code, how do you run it, and what is a pass or failure? Yes, last question.
You say free for HPSF projects. What about projects considering joining? Is there a way to kind of test it out and get a feel for how useful it is?
If you are considering joining HPSF, then yes, we will extend that and work with you. That will be a compelling reason for you to consider joining HPSF. So, yes. Well, thank you very much. We look forward to working with you. And please consider attending the other HPSF CI working group sessions to learn more about our work. Thanks.